There are places on Earth so contaminated that entering them for even a few minutes could expose you to radiation levels capable of permanently damaging the human body. Some were created by catastrophic nuclear disasters, others by secret military experiments carried out far from public view. A few are so deeply saturated with radioactive material that even decades after the events that created them, scientists still actively avoid disturbing them, because attempting to clean them up could trigger consequences far worse than simply leaving them alone. These aren't just dangerous zones cordoned off with warning tape. These are places where the soil itself has become a weapon, where the water carries isotopes that will remain lethal for thousands of years, where animals that wander in are found dead, and the ones that survive carry mutations scientists are still struggling to explain. What makes these locations uniquely terrifying isn't just the radiation, it's the combination of contamination so severe and so deeply embedded in the land that the world's most advanced nuclear science has been essentially powerless to reverse it. In some cases, the deeper scientists dig, the more they find. In others, the contamination has spread far beyond its original boundaries, silently reaching populations who never knew they were at risk. Today, we're counting down 10 of the most radioactive dead zones on Earth, locations where the ground, the water, and the air carry invisible dangers that will persist long after every human alive today is gone. These are places that challenge the limits of what science can fix, and in many cases, expose the darkest chapters of how governments treated their own people. Pay close attention as we approach number 1, because the most radioactive and most deliberately concealed location on this entire list is one that most people have never heard of, and its story is unlike anything else in nuclear history. Number 10. The Kyshtym Disaster Zone, Russia. In the fall of 1957, in a remote region of the Soviet Ural Mountains, something exploded that the Soviet government would spend decades trying to hide from the world. The Kyshtym disaster, named after the nearest town to the site, occurred at the Mayak nuclear processing facility, one of the Soviet Union's primary plutonium production plants, built in secret following World War II. On September 29th, a cooling system failure inside a storage tank containing highly radioactive nuclear waste caused a massive chemical explosion. The blast released an estimated 20 million curies of radioactive contamination into the atmosphere, an amount that, for context, represented roughly 1/5 of the total radiation released during the Chernobyl disaster 3 decades later. The explosion flung radioactive debris and aerosols across hundreds of square kilometers, a plume of contamination, later called the East Ural Radioactive Trace, stretched across a corridor roughly 300 kilometers long and 9 kilometers wide. More than 270,000 people lived within that corridor. The Soviet government began quietly evacuating some villages, but only days and weeks after the explosion, when many residents had already received significant doses. No public announcement was made. No explanation was given to the people being relocated. Many were simply told to leave and never come back. The long-term effects were devastating and systematically suppressed. Soviet authorities destroyed medical records. Doctors were ordered not to connect patient illnesses to radiation exposure. The region remained classified for decades, and the Western world only learned of the disaster in 1976, when Soviet scientist and dissident Boris Medvedev published accounts of it, and was initially dismissed as fabricating the story. Even today, the Kyshtym zone presents serious decontamination challenges. The radioactive isotopes released included strontium-90 and cesium-137, both with half-lives of approximately 30 years, meaning the land will carry measurable contamination well into the 21st century. Portions of the East Ural Nature Reserve established around the affected area remain off-limits to public access. The contamination isn't just on the surface. It has been absorbed into the ecosystem, taken up by plants, passed into animals, and cycled through soil in ways that make removal essentially impossible without destroying the landscape entirely. But the Kyshtym disaster, as catastrophic as it was, is only a preview of what this region of Russia was doing to its land and its people, because the facility at its center had been quietly poisoning the environment for years before the explosion, and continued to do so long after. That full story comes later on this list. Number 9. The Church Rock Uranium Spill, USA. Most Americans have never heard of the largest accidental release of radioactive material in United States history. That's not a coincidence. It's a consequence of where it happened and who it happened to. On July 16th, 1979, just 3.5 months after the 3 Mile Island incident had captured the entire nation's attention. A dam at a uranium mine tailings pond near Church Rock, New Mexico, quietly failed. The breach released approximately 94 million gallons of radioactive wastewater and over 1,000 tons of solid radioactive mill waste directly into the Puerco River. It remains the single largest release of radioactive material in American history. The Puerco River ran through the heart of the Navajo Nation. Within hours, contaminated water was flowing downstream through communities that depended on that river for drinking water, livestock, and agriculture. Children waded in the water before anyone warned them not to. Animals drank from it. Crops were irrigated with it. Federal and state emergency response was slow, disorganized, and, according to many historians and environmental justice advocates, strikingly inadequate compared to the response 3 Mile Island had received that same year. The radioactive contamination in the Church Rock area includes uranium, thorium, radium, and polonium, materials with half-lives ranging from decades to billions of years. The area is located in what geologists call uranium country, where natural deposits combined with decades of industrial mining have created a contamination landscape that is extraordinarily complex. Soil, groundwater, and the riverbed itself contain elevated radiation levels across a zone that extends for miles in multiple directions. Decontamination efforts have been ongoing for decades through the EPA's Superfund program, but progress has been agonizingly slow. The geology of the area means contamination has migrated into aquifer systems, and the sheer volume of contaminated soil is staggering. Some estimates suggest full remediation would require removing and disposing of millions of cubic meters of material, a task that would take generations to complete and has never been fully funded. Navajo communities continue to report elevated rates of cancer, kidney disease, and other health conditions linked to radiation exposure. Studies have detected uranium in the water and blood of Navajo residents at levels that remain above safe thresholds. The people of Church Rock have been living inside a radioactive dead zone for nearly half a century, and the cleanup is still nowhere near complete. What happened in New Mexico was a slow-motion disaster that the country largely looked away from. But the next location on our list involved an entire ocean ecosystem, and it was created entirely on purpose. Number 8, Eniwetok Atoll, Marshall Islands. Imagine an island paradise, white sand, turquoise water, coral reefs, turned into one of the most radioactively contaminated places on Earth through a deliberate campaign of nuclear weapons testing. That is the story of Eniwetok Atoll. Between 1948 and 1958, the United States military detonated 43 nuclear weapons at Eniwetok, part of the Marshall Islands in the central Pacific Ocean. The tests included some of the most powerful thermonuclear devices ever exploded, among them Ivy Mike in 1952, the world's first hydrogen bomb test, which vaporized an entire island from the atoll and left a crater over a mile wide in the ocean floor. The cumulative explosive force of all tests at Eniwetok was equivalent to roughly 1.6 times all the conventional weapons used in the entire Second World War. The indigenous Eniwetok people had been relocated before testing began, told it would be for the good of mankind and to end all world wars. They were never adequately warned it might be permanent. The contamination deposited across the atoll included plutonium-239, with a half-life of 24,100 years, cesium-137, strontium-90, and americium-241, among dozens of other isotopes. In the 1970s and 1980s, the U.S. military undertook what became known as the Eniwetok Cleanup, a massive effort involving thousands of U.S. service members who scraped contaminated soil from the islands and deposited it, along with radioactive debris from the tests themselves, into Runit Dome. Runit Dome is a crater left by a nuclear explosion that was lined with concrete and filled with approximately 111,000 cubic yards of radioactive material, then sealed with a concrete cap 18 inches thick. The problem is that the dome was never designed as a permanent solution. It was built quickly, under cost pressure, and the concrete cap has been cracking for years. As sea levels rise due to climate change, seawater increasingly inundates the atoll and may eventually overtop or undermine the dome entirely, potentially releasing its contents back into the Pacific Ocean. A 2020 report found that the radioactivity of water inside the dome is already leaking into the surrounding lagoon. And because the dome sits on a coral island, not bedrock, there is no impermeable barrier beneath it. Scientists have described Runit Dome as a ticking time bomb. The Marshall Islands government has called on the United States to accept responsibility for the dome's contents, but the U.S. government has maintained the dome is the responsibility of the Marshall Islands. Meanwhile, the original Eniwetak people who wish to return to their homeland still cannot safely do so on some islands of the atoll, more than 65 years after the last test was detonated. The next location shows that you don't need decades of weapons testing to create a catastrophe. Sometimes one ordinary Thursday afternoon is enough. Number 7. Goiânia, Brazil. In September 1987, 2 men entered an abandoned medical clinic in the city of Goiânia, Brazil, and removed a piece of medical equipment they planned to sell for scrap. Inside the machine was a small capsule of cesium-137, a highly radioactive isotope used in cancer radiotherapy equipment. They had no idea what it was. Neither did anyone else who would come into contact with it over the following days. The capsule was taken to a scrapyard where the owner noticed that the material inside glowed a vivid, captivating blue in the dark, a property of cesium-137 interacting with air that made it appear almost magical. He brought it home. Family members and friends were invited to see it. People rubbed it on their skin. A 6-year-old girl ate food that had been contaminated with it. The material was distributed to at least 4 households across the city before anyone connected the mysterious illnesses now spreading among the people who had touched it. By the time Brazilian health officials identified the source and declared a radiological emergency, 249 people had been contaminated. 4 died, including the 6-year-old girl. Dozens more were hospitalized with acute radiation syndrome, suffering skin burns, hair loss, vomiting, and organ failure. The contamination had spread across multiple city blocks, carried on shoes, clothing, and hands to homes, vehicles, and public spaces. The decontamination response was one of the largest urban radiological cleanup operations ever conducted. More than 85,000 people were assessed for exposure. 7 properties were demolished. Hundreds of cubic meters of contaminated soil, rubble, and personal belongings were excavated, sealed, and transported to a temporary storage facility on the outskirts of the city. But the aftershocks didn't end there. The storage facility faced intense local resistance, as no community wanted radioactive waste deposited near them. Legal battles dragged on for years. Some of the original contamination sites showed residual radiation levels measurable for more than a decade after the cleanup, and the psychological impact on the city was severe. Tourism collapsed, agricultural exports were rejected by other countries, and residents of Goiânia faced discrimination when they traveled, based on the false belief that they themselves were radioactive. The Goiânia incident revealed with horrifying clarity how easily radioactive material can escape containment in civilian settings, and how unprepared most societies are to respond when it does. It was a contained disaster. What comes next on our list is the opposite of contained. Number 6. Hanford Site, USA. If you were designing the most contaminated nuclear facility in the Western Hemisphere, you would design something very close to what already exists in the high desert of Washington state. The Hanford Site is a 580 square mile stretch of land along the Columbia River that produced the plutonium used in the Trinity test and the Fat Man bomb dropped on Nagasaki. And for the past 80 years, it has been leaking. During the Cold War, Hanford operated 9 nuclear reactors and 5 plutonium processing facilities at a pace and scale that prioritized speed over safety. The result was the creation of an estimated 56 million gallons of highly radioactive waste stored in 177 underground tanks, many of which were built as temporary structures in the 1940s and 1950s, and were never designed for long-term storage. At least 67 of those tanks have already leaked, releasing approximately 1 million gallons of radioactive and chemically toxic waste into the soil below. That contamination is slowly migrating toward the Columbia River, which serves as a drinking water and salmon habitat resource for millions of people downstream. The radioactive materials at Hanford include some of the most dangerous known to science: strontium-90, cesium-137, technetium-99, iodine-129, and plutonium in quantities that would be catastrophic if they reached the river in concentrated form. The cleanup project at Hanford is currently the most expensive environmental remediation effort in human history, with estimated total costs exceeding $677 billion and a projected completion date that has been pushed back repeatedly, now extending well into the 2060s at the earliest. If you're finding these radioactive locations fascinating, make sure to subscribe and turn on notifications, because the places still ahead on this list become even more dangerous and mysterious. The story of what nuclear contamination can do to a landscape, a population, and a government's willingness to be honest about it is far from over. The challenge at Hanford isn't just the volume of waste, it's the chemistry of it. The tanks contain a witch's brew of radioactive materials mixed with caustic chemicals, solvents, and biological waste, a combination that produces hydrogen gas, which has caused multiple near explosions inside the tanks. Engineers must simultaneously stabilize tanks at risk of rupture, treat leaked contamination in the soil, monitor groundwater approaching the river, and design a vitrification plant, essentially a machine to encase the waste in glass, that has never successfully been built at the necessary scale. The plant itself has been under construction since 2002 and has faced repeated safety, design, and engineering failures. Hanford is a wound in the American landscape that is not healing. But as catastrophic as it is, it doesn't even rank in the top 3 most contaminated sites on this list. The Soviet Union's relationship with nuclear contamination made the United States look restrained by comparison. Number 5, Mayak Nuclear Complex, Russia. You've already heard the name Mayak in connection with the Kishtim explosion. But what happened at the Mayak nuclear complex is not a single disaster story. It is a 70-year history of systematic, deliberate, and ongoing environmental contamination that may represent the most sustained radioactive poisoning of a civilian population ever conducted by any government. Mayak was built in secret, starting in 1945, operated in the Ural Mountains under the cover name Chelyabinsk 40, and was not acknowledged by the Soviet government to even exist until 1990. In its early years of operation, rather than store nuclear waste, which was expensive and technically challenging, the facility's managers simply released it. For years, radioactive waste from plutonium processing was discharged directly into the Teka River, which flowed through 38 villages and provided drinking water, fishing, and bathing resources for over 124,000 people downstream. Those people were not informed. They were not relocated. They were not told what was in the water. The contamination of the Techa River was so severe that radiation levels in some stretches reached tens of thousands of times above safe limits. Studies conducted after the fall of the Soviet Union found that residents of riverside villages had received average doses of radiation comparable to or exceeding those received by Hiroshima survivors. Rates of leukemia, solid cancers, and congenital birth defects were significantly elevated in exposed populations. And because the exposure had been deliberately concealed and medical records destroyed, the full human toll has never been and may never be accurately calculated. When the Techa River became too contaminated to keep using as a dump, Mayak's managers switched to Lake Karachay, a small closed lake with no outflow, which they used as a radioactive waste reservoir for decades. You will hear much more about Lake Karachay shortly, because it earns its own place on this list at the very top. The 1957 explosion and the construction of the East Ural radioactive trace were the third major contamination event caused by this single facility. Between the river dumping, the lake, and the explosion, the Mayak complex created a radiological disaster zone covering thousands of square kilometers that continues to show measurable above-background radiation levels today. The scale of what happened at Mayak dwarfs nearly every other nuclear contamination event in history, and yet it remains largely unknown outside specialist circles, because for decades, the Soviet Union classified everything about it, and even after the Cold War, the full documentation has never been fully released. Number 4, Semipalatinsk Test Site, Kazakhstan. For 40 years, between 1949 and 1989, the Soviet Union detonated 456 nuclear weapons, including 116 atmospheric tests. At the Semipalatinsk test site in northeastern Kazakhstan, the people living in the surrounding region were not evacuated, were not adequately warned, and in many cases were deliberately kept in the area, so Soviet scientists could observe the biological effects of nuclear exposure on human subjects. The polygon, as it was known, covers approximately 18,500 square kilometers of steppe. Over 4 decades of testing, it received a cumulative radioactive contamination load that specialists estimate as being equivalent to thousands of Hiroshima bombs. Soil samples from around the test site contain plutonium, cesium-137, strontium-90, and uranium at levels that far exceed international safety thresholds. At specific ground zero locations, radiation readings remain so elevated that unprotected visits are still restricted today. The human consequences for the approximately 1.5 million people who lived in the region during and after testing have been staggering. Studies published in peer-reviewed journals have documented significant increases in cancer rates, thyroid disorders, immune dysfunction, congenital birth defects, and psychological disorders among exposed populations and their descendants. Some research suggests that radiation-induced genetic damage may be detectable in the children and grandchildren of those who were most heavily exposed, meaning the biological consequences of what happened at Semipalatinsk are still being passed down through generations. Decontamination is, for all practical purposes, impossible at scale. The site is simply too large. The contamination extends too deep into the soil and too widely across the landscape. Kazakh authorities, with international support, have secured former nuclear infrastructure on the site, removed weapons-grade material that could be diverted, and restricted public access to the most heavily contaminated zones. But the land itself, the steppe, the soil, the groundwater, cannot be cleaned. It is what it is, and it will remain that way for centuries. The stories of the Semipalatinsk region have only recently begun to reach the wider world. Survivors describe watching mushroom clouds from their villages. They describe being told by Soviet soldiers that the flashes and shockwaves were nothing to be concerned about. They describe diseases arriving in their communities with no explanation, and official denials stretching for decades. But even this, 4 decades of deliberate nuclear detonation, does not represent the worst outcome on our list. The contamination at Semipalatinsk can at least be mapped, at least be measured in its totality. The next location defies those reassurances. Number 3, Fukushima exclusion zones, Japan. On March 11th, 2011, a magnitude 9.0 earthquake struck off the coast of Japan, generating a tsunami that overwhelmed the Fukushima Daiichi nuclear power plant and triggered the worst nuclear accident since Chernobyl. 3 reactor cores melted down, hydrogen explosions damaged reactor buildings. Radioactive material was released into the atmosphere and the Pacific Ocean over a period of weeks. More than 154,000 residents were evacuated from a 20-kilometer exclusion zone around the plant. More than a decade later, the decontamination situation at Fukushima is one of the most complicated in nuclear history, not because the radiation levels are uniformly catastrophic, but because of the extraordinary complexity of the contamination landscape and the unresolved technical challenges that remain. The primary contaminant of concern is cesium-137, which has a 30-year half-life and settles onto soil, vegetation, and surfaces where it can be transported by wind and water. Japan undertook a massive decontamination effort covering thousands of square kilometers, the largest urban and rural radiation cleanup ever attempted, removing topsoil, washing surfaces, and collecting contaminated material in 1 cubic meter black bags that were stacked across agricultural fields and roadsides across Fukushima Prefecture. By 2020, more than 14 million cubic meters of contaminated waste material had been collected. But the harder problem remains inside the plant itself. The 3 melted reactor cores have never been reached. The molten nuclear fuel, called corium, fused with reactor structures and is believed to have partially penetrated the containment vessels. No robot or human has been able to reach or assess the full extent of the fuel debris. The radiation levels inside the containment structures are so extreme that even purpose-built robots have been destroyed or incapacitated before completing their missions. One unit recorded radiation levels of 530 sieverts per hour in 2017, a dose that would kill an unprotected human in less than 2 minutes. Japan's government has stated that full decommissioning of the plant, including removal of the melted fuel, will not be completed before 2051. Many independent nuclear engineers believe that timeline is optimistic. The technical challenge of removing corium from damaged containment structures has never been solved anywhere in the world, and Fukushima represents 3 simultaneous meltdowns. Meanwhile, some former exclusion zone towns have been partially reopened, but many residents have not returned, and reconstruction is slow and uneven. The ocean water releases, including the long-delayed discharge of treated wastewater stored in tanks at the site, have continued to generate international controversy. What happened at Fukushima is ongoing. It is not a past disaster. It is a present one, but it is not the worst present disaster on this list. Number 2, Chernobyl Red Forest, Ukraine. When reactor number 4 at the Chernobyl nuclear power plant exploded on April 26, 1986, it released approximately 400 times the radioactive contamination of the Hiroshima bomb into the atmosphere. The exclusion zone established around the plant covers roughly 2,600 square kilometers and has been the subject of more study, more documentary coverage, and more public fascination than any other nuclear disaster site in history. But within that already extraordinary zone, there is one area that stands apart, a place so contaminated that it became a monument to radioactive destruction visible from the air. The Red Forest is a 10 square kilometer area of pine forest immediately adjacent to the Chernobyl plant. In the days following the explosion, the pine trees in this area absorbed so much radiation that they turned a distinctive reddish-brown color before dying, hence the name. Radiation levels in the Red Forest reached levels so extreme in 1986 that they are essentially without parallel in any civilian environment on Earth. Soil readings in the most contaminated areas exceeded 10,000 Roentgens per hour at the time of the disaster, a level capable of delivering a fatal dose to a human in minutes. The Soviet response to the Red Forest was to bulldoze the dead trees and bury them, along with the topsoil, equipment, and vehicles used in the cleanup, in trenches within the forest itself. This decision, made for practical cleanup reasons, has created an enduring problem. The buried contamination is still there, and studies show it is not decaying as expected. The wood in the buried trees has decomposed far more slowly than normal because the radiation has killed off most of the microbes and fungi that would normally break down organic material. This means the radioactive carbon and other isotopes locked in the buried wood are being released more slowly, but also more unpredictably than models predicted. New trees have grown back over the Red Forest, but they are growing in soil that remains extraordinarily contaminated, and their tissues show uptake of radioactive cesium and strontium. Wildlife in the area, including wolves, foxes, and birds, show measurable internal contamination. Long-term studies comparing animal populations inside and outside the exclusion zone have produced contested results, with some research finding population booms due to reduced human activity and others detecting chromosomal abnormalities and reduced fitness in birds and other species. Forest fires represent a particular ongoing threat. In 2020, a large wildfire burned through portions of the Chernobyl exclusion zone, including areas near the Red Forest, releasing stored radioactive particles back into the atmosphere. Monitoring stations recorded temporary spikes in radiation levels across Ukraine and neighboring countries. Scientists have warned that climate change-driven increases in fire frequency could make such events more common, effectively re-releasing contamination that has sat relatively stable in the soil for decades. The Red Forest is not a place where decontamination is technically being refused. It is a place where it is physically, practically impossible. The contamination is in the soil at depths and concentrations that cannot be addressed without removing the entire landscape, and doing so would expose workers to doses that no safety protocol could justify. It is left as it is, watched, monitored, but untouched, a 10 square kilometer wound in the European landscape that will carry its contamination for centuries. But even the Red Forest is not the most radioactive location on this list. We have been saving that for last, and nothing else on this list comes close to what lies at number 1. Number 1, Lake Karachay, Russia. There is a lake in Russia where standing on the shoreline for 1 hour would deliver a radiation dose sufficient to kill you. Not over the course of weeks or months, over the course of the following days, just 1 hour. That is not a theoretical number based on modeling or worst-case projections. It is a measured value, documented by Soviet and then Russian nuclear scientists who monitored the lake for decades while continuing to use it as a radioactive waste dump. Lake Karachay is a small, shallow lake located within the Mayak nuclear complex in the Ural Mountains. It covers approximately 0.5 square kilometers. For most of its existence, it was virtually unknown outside the classified world of Soviet nuclear administration. And for more than 40 years, from the early 1950s onward, it received direct discharges of liquid radioactive waste from plutonium processing operations at Mayak, making it, by virtually every measure, the most radioactively contaminated body of water in recorded human history. By the 1990s, The lake's sediment contained an estimated 4.44 exabecquerels of radioactivity, a number so large it is difficult to contextualize. For comparison, the total activity released by the Chernobyl disaster is estimated at approximately 5.2 exabecquerels across the entire environment. Lake Karachay, a pond barely larger than a few city blocks, contained radiation comparable in magnitude to one of the worst nuclear disasters in history, concentrated in one place. The specific isotopes present include strontium-90, cesium-137, and a range of transuranic elements, including plutonium and americium. Strontium-90 is particularly dangerous because it chemically mimics calcium in biological systems, meaning it is absorbed into bones and teeth, where it irradiates bone marrow and can cause leukemia and bone cancer. The concentration of strontium-90 in Lake Karachay's water and sediment was so extreme that the lake was essentially uninhabitable, not just by humans, but by most living organisms. In 1967, the lake partially dried out during a drought. Wind carried radioactive dust from the exposed lakebed across an area of approximately 2,700 square kilometers, exposing nearly 500,000 people to additional radioactive contamination. This event, a disaster within a disaster, received essentially no public acknowledgement from Soviet authorities. The Soviet and then Russian response to Lake Karachay was, for decades, to simply continue using it as a dump. When the contamination problem could no longer be ignored, the decision was made not to attempt decontamination, because removing the sediment would require handling some of the most radioactive material ever accumulated in one place, exposing workers to lethal doses even with maximum protective equipment. Instead, between the 1970s and 2000s, the lake was slowly filled in with hollow concrete blocks and solid materials, physically burying the sediment under the surface and eliminating the open water that had created the dust hazard. But filling in a lake does not remove its contamination. The radioactive sediment is still there, entombed beneath the fill material. Studies have detected the migration of radioactive materials from the lake's original footprint into the surrounding groundwater, reaching the Misheliak River system, raising concerns about contamination spreading beyond the immediate site. Russian authorities have consistently maintained that monitoring shows the contamination is contained, but independent verification has been limited, and the site remains under restricted access within the Mayak complex. What makes Lake Karachay uniquely chilling on this list is not just the scale of contamination, it is the deliberateness of it. Unlike Chernobyl, which was an accident, unlike Fukushima, which was triggered by a natural disaster. Unlike the weapons tests at Eniwetok or Semipalatinsk, which were at least framed as military necessity, Lake Karachay was created by a choice made by administrators who knew what they were doing and continued making it for decades, choosing to dump radioactive waste into a small lake near human settlements because it was cheaper and faster than storing it properly. Lake Karachay is the endpoint of a philosophy that treated nuclear contamination as someone else's problem, to be buried, hidden, classified, and left for the future to deal with. The future is now here, and the lake is still there, sitting beneath its concrete cap, leaking slowly into the ground. 10 locations, 10 examples of what happens when radioactive contamination exceeds the capacity of human science and human will to undo it. At number 10, the Kishtim Zone introduced us to the catastrophic legacy of Soviet nuclear secrecy. Church Rock showed us that radioactive injustice in America fell hardest on those with the least power to fight it. Eniwetok demonstrated how paradise can be systematically destroyed and then sealed under a crumbling concrete dome. Goiânia revealed how easily radioactive material can escape institutional control and what happens when ordinary people encounter it without warning. The Hanford site showed us that even the richest nation in the world has created contamination it cannot clean up. Mayak and Semipalatinsk stripped away any remaining illusions about how the Soviet Union treated its own citizens in the service of nuclear ambition. Fukushima reminded us that even modern, advanced nuclear programs are not immune to catastrophic failure, and that 3 melted reactor cores remain unreachable more than a decade later. Chernobyl's Red Forest is a permanent monument to a single night when everything went wrong at once. And then there is Lake Karachay, no accident, no military necessity, just a quiet, deliberate choice to poison a lake, and through it, the land and people around it for generations. Which of these locations shocked you the most? Was it the scale of what was hidden at Mayak, the crumbling dome at Eniwetok, slowly releasing its contents into the Pacific? The fact that Lake Karachay, the most radioactive place on Earth, remains largely unknown, while Chernobyl commands global attention? Let us know in the comments below. If you made it to the end of this video, you've just learned things about nuclear contamination that most people will never know. If you found it eye-opening, hit subscribe and turn on notifications, because we go this deep on every subject we cover. There is no shortage of hidden history, dangerous places, and stories the world has tried to forget. We'll be here to find them.